Now we will start studying about our topic that has been mentioned over here as Python for beginners. Master the basics in 60 minutes. Let us move to the next part where we will study about the objectives of the course. By the end of this video, viewers will understand what Python is and why it's popular. Learn how to write basic Python code. Grasp fundamental programming concepts. Be ready to explore Python further on their own. Let us move to the next part where we will study the course content. In the first part, you will learn about Introduction to Python, under which you will learn what is Python, why learn Python, tools required, and quick installation steps, Python 3.x. In the next part, explore writing your first Python program, under which you will understand Python editor, IDLE or VS Code, the print function, followed by an example. In the third part, learn about Python variables and data types, under which you will study variables, data types, and type functions to check data types. In the next part, gain hands-on experience on control flow statements, under which you will learn if-else statements, for loop, and while loop. Next, gain proficiency on functions in Python, under which you will understand what is a function, creating and calling a function, and arguments and return values. In the next part, explore lists and dictionaries, under which you will learn lists, dictionaries, and type function to check data types. Next, learn about file handling, under which you will understand in details about the opening and reading a file, writing to a file. Lastly, we will conclude the session with a respective conclusion. You should be interested in gaining knowledge about Python and its code functionalities, which you will be able to understand completely from this course. This course is specially designed and tailored for aspiring programmers looking to learn Python from scratch, build a solid programming foundation, and enhance their skills in data processing, analysis, and visualization using Python. So let us move to the main discussion part. As per this slide is concerned, here we will be studying about Introduction to Python. We will first read out the details that has been mentioned over here, and then we will discuss it. What is Python? High-level, interpreted, and versatile programming language. Created by Guido van Rossum. Released in 1991. Known for its simple and readable syntax. Supports multiple programming paradigms. Procedural, object-oriented, functional. Why learn Python? Easy to learn and use. Beginner-friendly syntax. Extensive standard libraries and third-party packages. Widely used in web development, Django, Flask, data science, NumPy, Pandas, Matplotlib, machine learning, TensorFlow, scikit-learn, automation, scripting, web scraping. So from these details we get to understand that Python is a high-level, interpreted, and versatile programming language created by Guido van Rossum and first released in 1991. It is known for its simple and readable syntax, which makes it easy for beginners to learn and use. Python supports multiple programming paradigms including procedural, object-oriented, and functional programming, giving developers the flexibility to choose the approach that suits their best. Its dynamic typing and automatic memory management make development faster and more efficient, while its large and active community ensures continuous improvement and support. Python is considered one of the easiest programming languages to learn due to its clear and readable syntax, which resembles natural language. Its extensive standard libraries and a vast ecosystem of third-party packages make it highly powerful and adaptable to different use cases. Python is widely used across various fields such as web development using frameworks like Django and Flask, data science with libraries like NumPy, Pandas and Matplotlib, machine learning using TensorFlow and scikit-learn, and automation for scripting and web scraping. Its versatility and broad application make it a valuable skill for developers and data professionals. The provided image highlights 4 key features of Python. Object-oriented, which means it supports object-oriented programming principles. High-level language that abstracts low-level details, making it easier to write code. Easy to learn, which is simple and readable syntax. And procedure-oriented, which means it supports procedural programming with functions. These features make Python versatile and easy to use for various programming tasks. So this can be said as per the details mentioned over here. Now let us move to the next particular slide. In this particular slide, we will be discussing in details about tools required. Let me first read out the details that has been mentioned over here and then we will discuss it. 1. Install Python. Download from https www.python.org. Install Python 3.x version. 2. IDE overview. Ideally, lightweight, comes with Python. VS Code, popular for coding, supports extensions. Jupyter Notebook, ideal for data science and visualization. So from this part, we can understand that to start working with Python, the first step is to install Python from the official website. It is recommended to install the latest Python 3.x version for the most up-to-date features and support. After installing Python, you will need an integrated development environment, also known as IDE, to write and run your code. Ideally is a lightweight IDE that comes bundled with Python, making it easy to use for beginners. VS Code or Visual Studio Code is a widely used code editor known for its powerful extensions and debugging support, making it suitable for larger projects. Jupyter Notebook is particularly useful for data science and visualization because it allows you to write code and see the output in an interactive format, which is ideal for testing and presenting data-driven results. The provided image shows the types of Python tools in a circular format. It highlights 3 main types: integrated development environments, IDEs, used for writing and debugging Python code, Python packages, collections of modules that extend Python's functionality, and virtual environments, VEs, which is isolated environments that allow you to manage dependencies separately for different projects. So this can be said as per the details mentioned over here. Now let us move to the next part. Here in this mentioned part, we will be discussing about the quick installation steps. We will first read out the details that is mentioned over here and then discuss it. Go to https www.python.org. Download Python 3.x latest stable version. Install using the default installer. Verify installation Python version. Open your preferred IDE and start coding. So from this part we can say that to install Python you have to visit python.org and download the latest stable version of Python 3.x suitable for your operating system. It can be either Windows, macOS or Linux. Once downloaded, run the default installer and follow the on-screen instructions, ensuring that the option to add Python to path is selected during the installation phase. After installation, open a terminal or command prompt and type Python version to confirm that Python is installed correctly. If the installed version number appears, it means Python is set up successfully. Finally, open your preferred IDE such as IDE for basic use VS Code for advanced coding or Jupyter Notebook for data science and start your coding journey. So that is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. As per the slide is concerned, here we will be studying about writing your first Python code. We will first read out the details that has been mentioned over here and then we will discuss it. 1. Open a Python editor. Open ideally comes with Python or VS Code requires installation. Create a new file and save it with a .py extension. Example, first program.py. 2. The print function. The print function is used to display text or values on the screen. Syntax: print your message here. Prints strings, numbers and expressions. 3. Example, Python code. Print hello world. Print calls the built-in function to display output. Hello world. String value passed as an argument. Output appears in the console or terminal. So from these details we get to understand that to write your first Python program, you will have to open a Python editor like ideally, which comes with Python, or VS Code, which you will have to install separately. You will need to create a new file and save it with a .py extension. Example, first program.py. To display text or values on the screen, you will have to use the print function. The syntax is print your message here, where the message can be a string, number or an expression. For example, you will have to write print hello world to display the message hello world on the screen. You can also display expressions like print 5 plus 3, which will output to 8. The print function will help you to test and debug your code by showing the output directly in the console or terminal. The provided Python code showcases how to use the print function to display a message. You will have to write print hello world in your Python file to output the text hello world on the screen. The print function takes a string, in this case hello world, as an argument and outputs it directly to the console itself. The code section in the image highlights the Python syntax, while the output section shows the expected result when you run the program. This is most basic Python program and helps you confirm that Python is installed and working correctly. So that is everything that can be said as per the details mentioned over here. Now we will move towards the next discussion part. So in this particular slide, we will be discussing in details about Python variables and data types. Let me first read out the details that has been mentioned over here and then we will discuss it. Variables. A variable is a container for storing data values. It allows you to store and manipulate information in a program. Rules for naming variables. Must start with a letter A to Z or capital A to Z or underscore. Can contain letters, numbers and underscores. Case sensitive. Name and name are different. Cannot use Python keywords. Example, if, else, class. Avoid starting with a number. Example, Python code name is equals to Alice, assigning values to variables. Age is equals to 25. Print name, printing values. Print age, name is equals to Alice, assigns the string Alice to the variable name. Age is equals to 25, assigns the integer 25 to the variable name. Print name displays the value of the name in the console. Print age displays the value of the age in the console. So from this part, we can say that in Python, a variable is a container for storing data values, allowing you to store and manipulate information within a program. You will have to follow specific rules while naming variables. A variable name must start with a letter or an underscore and can include letters, numbers and underscores. Python variables names are case sensitive, meaning small name and capital name will be treated as different variables. You cannot use Python keywords like if, else or class as variable names. Also, you will have to avoid starting a variable name with a number as it will cause a syntax error. For example, my var is equals to 10 is a valid variable, but 1 var is equals to 10 will result in an error. Following these rules ensures that your code is readable and avoids conflicts with Python's built-in syntax. In the provided Python code, name is equals to Alice assigns the string Alice to the variable name, and age is equals to 25 assigns the integer 25 to the variable age. The print function is used to display the values stored in these variables. When you write print name, it outputs Alice to the console and print age outputs 25. Python allows you to store different types of data in variables such as strings, text, integers, whole numbers, floats, decimal numbers and more. The variable type is determined automatically based on the assigned value, so you do not need to declare the type explicitly. So this can be said as per the details mentioned over here. Now let us move to the next part. So here in this mentioned part, we will be studying about data types. We will first read out the details that is mentioned over here and then discuss it. A data type in Python defines the type of value that a variable can hold and determines what kind of operations can be performed on it. Every value in Python has a specific data type. Common data types: string str, sequence of characters, integer int, whole numbers positive or negative, float, decimal numbers, boolean, bool, represents true or false. Example, x is equals to 5 assigns an integer value, y is equals to 3.14 assigns a float value, z is equals to true assigns a boolean value, name is equals to Alice assigns a string value. Checking data types: print type x, output class int, print type y, output class float, print type z, output class bool, print type name, output class str. So from these details we get to understand that in Python a data type defines the type of value that a variable can hold and determines the operations that can be performed on it. You'll have to understand that every value in Python has a specific data type and Python automatically assigns the data type based on value assigned to a variable. Common data types include string, str, which is the sequence of characters enclosed in quotes, integer int for whole numbers positive or negative like 10 or -5, float for decimal or fractional numbers like 3.14, and boolean for representing true or false values. Understanding data types is essential because it helps you apply appropriate operations on variables and avoid type errors during execution. In the provided Python code, you will have to use different types of values and understand how Python assigns and handles data types. The statement x is equals to 5 assigns an integer value int to the variable x. The statement y is equals to 3.14 assigns a float value float to the variable y. The statement z is equals to true assigns a boolean value bool to the variable z, which can only be true or false. The statement name is equals to Alice assigns a string value str to the variable name. The type function is used to check the type of each variable. When you execute print type x, Python will display class int confirming that x is an integer. Similarly, print type y, print type z and print type name will confirm the types as float, boolean and string respectively. Understanding how Python assigns and handles different data types is important for writing efficient code and avoid type related errors. So this can be said as per the details mentioned over here. Now let us move to the next particular slide. In this particular slide, we will be discussing in details about dynamic typing in Python. We will first read out the details that is mentioned over here and then discuss it. Python is dynamically typed language. No need to declare the data type. Type is determined at runtime based on assigned value. Example, Python code x is equals to 5. X is an integer. X is equals to hello. X now is a string. So from this part we can say that in the provided Python code x is equals to 5, it initially assigns an integer value to the variable x. So x is treated as an integer. However, when you later assign x is equals to hello, the type x changes to a string automatically. So Python allows this flexibility because it determines the type of a variable at runtime instead of requiring a fixed type declaration. This feature makes Python more adaptable, but it requires you to be careful when assigning variables to avoid type-related errors in your code. Python will update the type of x to a string without any error. This flexibility allows you to write more concise code, but you need to be cautious about unexpected type changes during the execution phase, which could lead to runtime errors. Dynamic typing makes Python more flexible and easy to use, but you'll have to be careful with type consistency when handling complex operations. So that is everything that can be said as per the mentioned details. Now we will move on to the next discussion part. As per this slide is concerned, here we will be discussing about control flow statements. Let me first read out the details that has been mentioned over here and then we will discuss it. Control flow statements allow you to make decisions and execute different code blocks based on conditions. If-else statements used to execute a code block based on a condition. If the condition is true, the if block executes. If the condition is false, the else block executes. Syntax: if condition, hash code to execute if condition is true. Else, hash code to execute if condition is false. Example, Python code. Age is equals to 20 if age greater than 18, print adult, else print minor. If age greater than 18, checks if the value of age is greater than 18. Print adult executes if the condition is true. Else executes when the condition is false. Print minor executes if the condition is false. So from these details we get to understand that control flow statements allow you to make decisions and execute different code blocks based on specific conditions. The if-else statement is used to execute a code block based on whether a condition is true or false. If the condition is true, the code inside the if block will execute, otherwise the code inside the else block will execute. The syntax involves using the if keyword followed by a condition and a colon, with the intended code underneath, representing the code block to execute if the condition is true. The else keyword is used to define the code block that will execute if the condition is false. In the provided Python code, the variable age is assigned the value 20. The if statement checks if age is greater than 18. Since the condition is true, the statement print adult will execute displaying adult. If the value of age had been less than equal to 18, the else block would have executed displaying minor. This demonstrates how if-else statements help control the logical flow of a program based on conditions. So this can be said as per the details mentioned over here. Now let us move to the next particular slide. In this particular slide, we will be studying about for loop. We will first read out the details that has been mentioned over here and then we will discuss it. A for loop is used to repeat a block of code a fixed number of times or to iterate over items in a collection, like a list or string. Syntax: for variable in iterable, hash code to execute. Variable: temporary value that makes on each element in the sequence. Iterable: a collection of values. like a list, tuple or string. Iterating over a range. The range function generates a sequence of numbers. Syntax: range, start, stop, step. Start, starting value default is equals to 0. Stop, end value exclusive. Step, increment value default is equals to 1. Looping through a list. You can loop through elements of a list directly. So from this part we can say that a for loop is used to repeat a block of code in a specific number of times to iterate over items in a collection, such as a list, tuple or string. The syntax for a for loop includes the for keyword followed by a variable name, the in keyword and the iterable object. The variable temporarily stores each element of the iterable during each loop iteration. The range function is often used with for loops to generate a sequence of numbers, and it follows the syntax range, start, stop, step, where start is the starting value which is default 0, stop is the end value which is exclusive, and step is the increment value which is default 1. For example, range 1, 5 generates the sequence 1, 2, 3, 4. So you can also loop through a list directly using a for loop by assigning each element to a variable during each iteration. This makes for loops highly effective for processing data collections and automating repetitive tasks. The first provided example demonstrates how to use a for loop to iterate over elements in a list. In the code, a list named fruits is defined with 3 elements: apple, banana and cherry. The for loop is written for fruits in fruits, where fruit is a temporary variable that takes on the value of each element in the list one by one. Inside the loop, the print fruit statement prints the value of fruit during each iteration. As a result, the output displays apple, banana and cherry on separate lines. This example shows how you can directly loop through a list to access and process each elements. The second example, on the other hand, shows how to use a for loop with the range function. The code for I in range 5 creates a loop that generates numbers from 0 to 4, since the stop value is exclusive. The range function generates a sequence of numbers starting at 0, which is default, and ending before 5. Inside the loop, the print I statement prints the value of I during each iteration. Therefore, the output displays 0, 1, 2, 3 and 4 on separate lines. This example shows how you can use the range function to control the number of loop iterations. So this can be said as per the details mentioned over here. Now we will move on to the next part. So here in this mentioned part, we will be discussing about while loop. We will first read out the details that has been mentioned over here and then we will discuss it. A while loop is used to repeatedly execute a block of code as long as a specified condition is true. Syntax: while condition, hash, code to execute. Condition: a logical expression that evaluates to true or false. The loop runs while the condition remains true. Example: Python code. Count is equals to 0 while count less than 5. Print count. Count plus is equals to 1. Count is equals to 0 initializes the variable count, while count less than 5. The loop checks if count is less than 5. Print count outputs the current value of count. Count plus is equals to 1 increments count by 1 in each iteration. Loop stops when count reaches 5. So from this part, we get to understand that a while loop in Python is used to repeatedly execute a block of code as long as a specified condition evaluates to true. The loop starts by evaluating a logical expression or condition, and if the condition is true, the code block inside the loop is executed. After each execution, the condition is re-evaluated and the loop continues running until the condition becomes false. In the provided example, the variable count is initialized to 0, count is equals to 0. The while loop checks if count is less than 5 while count less than 5. If the condition is true, the print count statement outputs the current value of the count. After printing count plus is equals to 1, increases the value of count by 1 in each iteration. The loop stops when count reaches 5 because the condition becomes false. This example demonstrates how a while loop can be used to execute code repeatedly based on a logical condition. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So as per this slide is concerned, here we will be studying about functions in Python. We will first read out the details that has been mentioned over here and then we will discuss it. What is a function? A function is a reusable block of code that performs a specific task. Functions help to organize code, reduce repetition, and improve readability. You can define your own functions or use built-in ones, print, len, etc. Creating a function. Use the def keyword to define a function. A function can take parameters, input values. Use the return keyword to send back a value, optional. Syntax. Def function name parameters, hash code block. Return value, hash optional. Example, Python code. Def greet name hash defines a function named greet that takes one parameter. Printf hello name hash outputs a formatted string using the name parameter. Greet Alice hash calls the greet function with the argument Alice. So from these details we can say that a function in Python is a reusable block of code that performs a specific task. Functions help you organize code, reduce repetition, and improve readability. You can define your own functions or use built-in ones like print and len. To create a function, you will have to use the def keyword followed by the function name and parenthesis that may include parameters. A function can take parameters like input values and use the return keyword to send back a value through returning a value which is optional. In the provided example, the function greetName is defined using the def keyword with name as a parameter. Inside the function, the print hello name statement outputs a formatted string that includes the passed parameter. The function is called using greet Alice, which passes the string Alice as an argument. The function then executes and outputs hello Alice. This example demonstrates how you will use to define and call a function, pass arguments and output values using a function in Python. So this can be said as per the details mentioned over here. Now let us move to the next particular slide. In this particular slide, we will be discussing in details about arguments and return values. Let me first read out the details that has been mentioned over here and then we will discuss it. Arguments. Values passed to a function when it is called. Return value. Value that a function sends back to the caller using the return statement. Arguments allow you to pass data into a function. Return values allow you to get results from a function. Example, Python code. Def add a, b, return a plus b, result is equals to add 3, 4. Print result. Def add a, b defines a function add with two parameters a and b. Return a plus b returns the sum of a and b. Add 3, 4 calls the function with the arguments 3 and 4. Result is equals to add 3, 4. Stores the return value 7 in result. Print result outputs the result returned by the function. So from this part we can say that in Python, arguments are the values you pass to a function when you call it. and the return value is the result that you send back to the caller using the return statement. Arguments allow you to pass data into a function, while return values allow you to get results from a function. In the provided Python code, the function add a, b is defined with two parameters a and b, which represent the values passed to the function. The statement return a plus b returns the sum of a and b to the caller. When the function is called using a add 3, 4, the values 3 and 4 are passed as arguments, and the function returns the sum 7. This return value is stored in the variable result, which is then printed using print result. This demonstrates how you will use pass arguments into a function and return a value from it in Python. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. As per this slide is concerned, here we will be studying about lists and dictionaries. We will first read out the details that has been mentioned over here and then we will discuss it. Lists. A list is an ordered, mutable collection of elements. Lists can store elements of different data types, integers, strings, floats, etc. Lists are defined using square brackets. Creating a list. Lists are created using square brackets. Elements are separated by commas. Example Python code. Numbers is equals to 1, 2, 3, 4. Print numbers. Manipulating and accessing elements with indexing. Indexing starts at 0, first element. Use negative indexing to access elements from the end. Append. Adds an element at the end of the list. Insert. Adds an element at a specific index. So from these details we get to understand that in Python, a list is an ordered, mutable collection of elements that can be stored in different data types such as integers, strings, and floats. Lists are defined using square brackets and elements are separated by commas. For example, numbers is equals to 1, 2, 3, 4 creates a list named numbers containing 4 integer elements. You can access elements using indexing, where indexing starts at 0 for the first element, and you can use negative indexing to access elements from the end. Lists are mutable, which means you can modify them after the creation. The append method allows you to add an element at the end of the list, while the insert method allows you to add an element at a specific index. The provided image shows an example of list manipulation in Python. In the code, numbers is equals to 1, 2, 3, 4 creates a list named numbers containing 4 integer elements. The append method is used to add an element to the end of the list. So numbers.append 5 adds 5 to the end, making the list 1, 2, 3, 4, 5. Next, the insert method is used to add an element at a specific index. So numbers.insert 2, 7 inserts 7 at index 2, shifting the existing elements to the right. After the insert operation, the list becomes 1, 2, 7, 3, 4, 5. The print numbers statement outputs the modified list, which is shown in the output section of the image. This example demonstrates how you will have to use the append and insert methods to modify lists in Python. So this can be said as per the details mentioned over here. Now let us move to the next particular slide. In this particular slide, we will be discussing in details about dictionaries. Let me first read out the details that is mentioned over here and then we will discuss it. A dictionary is an ordered collection of key value pairs. keys must be unique and immutable. Example, strings, numbers, tuples. Dictionaries are defined using curly braces. Creating a dictionary. Define key value pairs using key is to value. Example, Python code. Person is equals to name is to Alice, comma, age is to 25. Print person. Accessing values. Use square brackets key to access values by key. Example, Python code. Person is equals to name Alice, age 25. Print person name hash output Alice, print person age hash output 25. So from this part we can say that in Python a dictionary is an unordered collection of key value pairs where keys must be unique and immutable, such as strings, numbers or tuples. Dictionaries are defined using curly braces and stored in a data of a key value format. For example, in the first provided Python code, person is equals to name Alice, age 25 creates a dictionary named person with two key value pairs, name with the value Alice and age with the value 25. You can access dictionary values using square brackets and specific keys. For example, in the second provided Python code, print person name will output Alice and print person age will output 25. This allows you to efficiently store and retrieve data using meaningful keys instead of relying on positional indexes. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So as per this slide is concerned, here we will be studying about file handling. We will first read out the details that has been mentioned over here and then we will discuss it. File handling allows you to read from and write to files. Python provides built-in functions for file operations. Files are accessed using the open function. Opening and reading a file. R opens a file in read mode. With ensures proper closing of the file after the operation. Example, Python code. With open sample.txt R as file. Content is equals to file.read. Print content. Writing to a file. W opens a file in write mode. Creates file if it doesn't exist. Overrides existing content. Example, Python code. With open output.txt, W as file. File.write. This is a test. So from these details we get to understand that file handling in Python allows you to read from and write to files using built-in functions. The open function is used to access files, where the mode specifies the type of operation. R for reading and W for writing. To read a file, the with statement is commonly used because it ensures that the file is properly closed after the operation. For example, in the first provided Python code, with open sample.txt, R as file opens the file sample.txt in read mode and file.read reads its content, which is then printed. To write to a file, you can use the W mode, which creates the file if it does not exist and overwrites the existing content. For example, in the second provided Python code, with open output.txt, W as file opens the file output.txt in write mode and file.write. This is a test. Writes the string. This is a test to the file. File handling is essential for working with external data and saving program output. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So in this particular slide, we will be studying about the conclusion. We will read out the details first and then we will discuss it. In this session, you have learned the core concepts of Python programming, including variables, data types, control flow, functions, lists, dictionaries, and file handling. These foundational skills will enable you to start building simple projects and writing efficient Python code. To reinforce your learning, try creating small projects like a calculator, a to-do list, or a text file analyzer. For further learning, explore resources like Python's official documentation, Free Code Camp, W3 Schools, and Real Python. Key practices consistently to strengthen your understanding. So from this part, we can say that the conclusion summarizes the key Python programming concepts you have covered in the session, including variables, data types, control flow statements like if-else, for loop, and while loop, functions, lists, dictionaries, and file handling. These concepts are essential building blocks for writing Python code and creating projects. The conclusion suggests that you will have to apply these concepts by working on small projects like a calculator, a to-do list, or a text file analyzer to reinforce your learning. It also encourages you to use resources like Python's official documentation, Free Code Camp, W3 Schools, and Real Python for deeper learning. So this is everything that can be said as per the mentioned details.